Everything is clear. Okay, good. So let us continue. We have been discussing about SDLC models, various models for defining right processes for the software development lifecycle. I hope the slide is visible, right? Are the
Yes, sir.
okay, okay. So in terms of the SDLC model, just for a quick recap, we have a variety of models, some of which are improvements on the other, and all of these models and different contexts are in use in the industry as of now. So we first talked about the waterfall model, where, as the name suggests, it's precisely every step is completed, and then the next step is done. Requirements analysis, design, code, test, deployment, maintenance go one after the other. It's a linear model without any feedback, and the customer engagement is only at the beginning of the SDLC here, when you are acquiring requirements, and then only at the end when you are ready to deploy. So it has naturally a lot of potential to go wrong, and therefore, though it is good for the reason that it is easy, it is well defined, uh, but it requires a kind of stability of the requirements, and it provides very good quality, because but it's not often uh, best suited when you have quick turnaround. So waterfall is still probably the most widely used, uh, even in spite of its shortcomings, but limited to either small projects, academic projects, or mm, very well-defined large product developments and so on. So we saw that the main problem of what waterfall model is the fail late life cycle. That is the sense you have the tests being done only at the end, and then the customer verification, customer validation, user acceptance is being done after that. So naturally, the often the bugs or the errors are detected much later, and which has a lot of impact of risk. So risk becomes very high in that. Now, based on these observations, there have been a lot of improvements that people have tried out. The first is a nice model, which is iterative incremental kind of model, right? So, and as you will see, this has become the backbone for many of the later models, which are currently more used. The idea here is very simple, that you break up the entire product development life cycle in terms of small iterative steps, right? So iteratively, you are refining and incrementally providing support. So maybe the first iteration, as you do, the leftmost that you can see, that by itself is a waterfall, but it is probably not implementing everything. It is doing a partial implementation, maybe the very necessary concepts only, and maybe just the just the success parts, not the possible failure parts, and so on. It may, for example, uh, if the software has GUI requirements, possibly initially you do not have the GUI, you are just doing a text-based inputs and so on. So the idea is that you break it up in terms of such possible stage by stage refinement. so that you don't start with the entire project in one go, but develop it in stages. And every stage is called an iteration. And one particular iteration, I mean, how you design is obviously very subjective, and it depends on the product, depends on the project, and the manager who is deciding on all this. But within one iteration, you follow a waterfall, and uh, the important thing is the iteration should not be very long. For example, if the entire project life cycle is estimated to be 6 months, maybe an iteration would be 1 month, or maybe 6 weeks, and so on. So that you can have multiple iterations. And the key part of this is naturally, when you do this iteration, at the beginning of the iteration, you are engaging with the customer to get the requirements. And from there, you have chosen a subset and you implement that. And you have some functional product ready, which you actually go back to the customer to show that, to demonstrate. And then, based on that demonstration and feedback and the original requirements, you define the or refine the requirements for iteration, and you keep on doing that. I mean, as many iterations as you have planned. So the strengths are naturally initial delivery of the product is faster, lower initial delivery cost, change of in requirements can be easily adjusted because you are iterating through it and you are not implementing everything in one go. And most importantly, the customer has much better engagement with the project compared to waterfall, because the customer is not only at the beginning and end, but its customer is there at the start and end of every iteration. So it's better in that way. But it does have shortcomings, there are requirements for effective iteration planning, which is an additional overhead. Efficient design is required, which can be broken down. Clear module interfaces are required, which are in a way good, but kind of slows down, puts some overhead on that. But certainly, in this way, you can reduce the risk of waterfall to a good extent, right? So that's kind of a direction that, and also other problems of other business related problems of waterfall that I had mentioned, like billing cycle and all that, can be much better managed, because now, since you are showing the progress and the demonstration at the end of every iteration, raising invoices to the customer becomes easier. So it's more, business friendly kind of SDLC. The third, which is kind of used in some cases, is called a V-shaped model, and or simply V model. And this word V has three connotations here. One is, as you can see, the entire flow looks like the letter V. And the other two connotations are, there is a verification phase and there is a validation phase of the model. So if you look at this carefully, if you look down the verification phase, you will see that the first few stages are in the verification phase, which means that this is when you are defining what the project will do. You are acquiring the requirements, you are analyzing them, you are doing a system level design, then coming down to high level design, low level design, and so on. And if you look at the path up in the validation phase, you have varied kinds of testing, going from a very simple unit level testing to integrating different modules, then integrating at a system level, and finally the user acceptance testing. Okay. So these arrows tell you the path around. So if you just follow these arrows, with coding being the substantial bottom line, this actually, if you follow these arrows, it actually is a waterfall. But the difference is the cross arrows, which say that you do not wait for the testing related activities like you do in waterfall till the end of coding. Rather, at every phase of verification, when you are defining it, you are defining the corresponding process to validate that. That if this is my requirement, what will be my acceptance? Right? So customer is completely engaged in that. If this is my system design, then how am I going to test the system once it is coded? So what is the system? So there are a whole lot of these cross arrows show that as you are going along the verification phase, going down with that, the corresponding testing requirements, test plans, and all those are being done at a lateral level, right? So you are actually defining the requirements, analyzing them, and defining the acceptance testing. So you are actually not doing the testing. The testing will be done when you come up because you do not have a code to test, but you are defining the test plan as to what you will have to test. Right? So that, and you are validating that with the customer most often. So this V model gives a much better quality at much lesser cost, usually in general, and often involves parallel teams. One is a verification team, another is a validation team, so that these things can go in parallel. So it is simple, easy, understandable model. It's good for small projects, but it's not very good. V-shaped model is not good for ongoing projects. Like if you already have a system which is implemented, deployed, and you are fixing bugs on that, or you are kind of say uh, working on a major enhancement for that, then the V-shaped model will not be good because all these progressive definitions will not be applicable. Right? And also the same difficulty as of waterfall, that the requirement change at a later stage could cost too high. Right? So that is a kind of trade-off which we saw is better in the iterative incremental model. So, and you can note that we talked about when we talked about effectiveness and efficiency, we talked about these two things, that it is important to build the right system, and it is important to build the system right. So the verification basically is the process of building the right system, because that is where you are designing, defining what your product is going to be. Whereas validation is a whole lot of variety of ways to test and validate, to check that the system that you have built is the right system, right? So the first one gives you effectiveness, and the second one gives you efficiency, as we have seen. So going forward, now naturally all of these were kind of not being satisfactory to the to the customer and the environment. So what evolved is called a RAD model, which is basically a refinement of prototyping model. So what does prototyping say? That and it's kind of when if you talk about iterative refinement, you're saying that you are breaking it down into phases to do things. In a RAD model, you try to build small prototype of whatever you are required to. Right? So it's in that way, it has a similar principle, but the focus here is not merely on the execution through iteration. The focus here is at every point, you must have a prototype which is well defined, which can be shown to the customer and can be further refined. So you can see the cycles here, that you first gather the requirements, which has to be an independent activity. Then do a design for the first prototype. So you design and prototype. Prototype here means naturally you code for that as well as test for that. And once it is done, you are doing a customer evaluation, you are doing a validation. So the customer actually is getting into this loop. customer is coming in every time. You create a new prototype, you demonstrate and validate with the customer to get a refined, to define a refined prototype. And then you do the design for that and do the prototype. So this feedback loop I mean, this iteration is similar to the iterative refinement model, but kind of more well defined in terms of requirements of prototypes. And you keep on cycling through this till you have a refined prototype, which is the acceptable final product. Right? So RAD is becoming naturally become more and more popular. So you can see this looks pretty much like the like the iterative refinement, but the sense here is somewhat different. Is here from the beginning to the end of a particular iteration cycle, uh, prototype iteration cycle. You have multiple teams which are actually working because you are working on smaller, well-defined tasks, and they are working in parallel. And that way, you can shorten the overall time for the project. And a typical, RAD cycle is typically of 60 to 90 days. Okay. So 2 to 3 months is what you do a cycle. So it can reduce the cycle time and enhance the productivity with minimal team members, because uh, you are reusing the team members in every iteration of the prototype, and the customer is continuously involved. So that minimizes the risk of not achieving the satisfaction of the customer. So, and it's naturally more amenable to accommodate changes as the development goes on. But certainly, that cannot be applied on everything. For example, it is very hard to use and implement with the legacy systems, the systems that exist. And because there's a lot of business in software development exists in terms of legacy system migration. That I had a system, say, for example, designed in Google, and I want to migrate it to relational database. Right? Or I have a system designed, a system which works in C, and I want to migrate it to C++ for better quality, wider service, better APIs, and so on. I may have a system which works perfectly on 32-bit processors, and I want to migrate that to 64-bit processor. Which is as the processor capabilities change, these kind of migration requirements come up. So these are called legacy system. Legacy is a relative term. Legacy does not mean 100 years back. Legacy does not. I mean, something which was done maybe even 5 years back, 2 years back, could be considered as a legacy system if fundamental parameters of development have changed. Right. So RAD cannot be used very well. It's good for fresh projects, but it's not at all good for the legacy systems because they are already in existence and they have a full-blown model. So there's unless you just want to, imitate the functionality of the existing legacy system and want to build a completely new one, which usually you do not do because there are a lot of cost implications for that. So it is not very easy to do this prototyping and iteration on that. Right? So every model has some limitations and some strengths, as you can see. So customer is at the prototyping works well for fast development priorities because customer is regularly getting something, but works for smaller development and development for estimation. Particularly, this point is very important that not always you develop only for the actual delivery. But suppose if you have a big project, suppose you estimate that this is a 100-man-year project, right? So probably 50 people will work for 2 years in this project. Now, the question is, when you get the specification, how do you make an estimation of this time? How do you make an estimation of the cost? Many things are so entangled, and just by looking at the requirement, even if you are an experienced developer, an experienced project manager, it becomes difficult to put on an estimation. So what companies take recourse to is they they just scan out whatever are the core requirements and build prototypes for that through a RAD model and sees what I mean, are we getting the ideas right? Are we getting the right design models? Are we on the same right track to satisfy the customer, and estimates the resource requirements for doing this rapid development, and that works as a core for the estimation for quoting for the project. So the the SDLCs could have multiple such things. You obviously cannot do a waterfall for such things. You cannot do iterative refinement, iterative incremental in general, because you will not have that much of time. But you can do rapid prototypes for this. And that's basically where the RAD originally came in, that you need a rapid prototyping to see the basic idea is functional and it's doable and it's affordable in terms of the resources and so on. So Spiral is another model which basically works combines risk analysis and RAD prototyping to waterfall. So Spiral is, as you can see, the name is given. So there are 4 quadrants. Numbered as left top is numbered 1, not the usual way in coordinate geometry we number the coordinates. We call this one as 1. No, this one left top is 1. So this does determines the objectives, alternative, and constraints. Then you evaluate the alternatives, identify and resolve risks. So in the Spiral model, the additional component is risk analysis. That at every stage of the spiral, you are keeping the risk in mind. That what if it fails? What are the factors for which it can fail? And what are the consequences of that failure? In terms of cost, in terms of time, in terms of quality, in terms of customer satisfaction, and so on and so forth. So you determine objectives, evaluate alternates with risk, and then you develop the next level of the product. And then in the 4th quadrant, you plan for the next. So you can see that this is basically RAD, shown in a different way. In RAD also you were cycling through, but the specific name Spiral model has evolved with the specific connotation of involving risk analysts in the whole process. There are specialists as risk analysts which analyze the risks that are involved, and these Spiral models and all have come into SDLC from other areas of engineering like civil construction and so on, where you regularly do these kind of things. So it's good in terms of getting an early indication of risk is always helpful, and the user is involved in all life cycle stages. Customer is at every spiral round, but it can be difficult, as in the RAD or the refinement itself. For example, it may be hard to set objectives or verifiable milestones, because unless you have verifiable milestone, you cannot actually assess the risk in the right way. So in the 4th quadrant, we're planning for the next phase, the next iteration. This could be really difficult task. And then certainly you have additional time and effort needed for addressing the risk, estimating them, And in the process, many projects have done very well, but many projects have also, tend to go on indefinitely. Right? It's a spiraling. It improves quality, reduces rework, but may slow down the overall development. Right? So if it slows down, then even though it has improved the quality, which means that you are providing working for a better customer satisfaction, better money. It is reducing rework, so it is reducing your cost, better profit. But if it slows down the development, then in that process, you are incurring more cost in terms of paying for your resources, whether it is infrastructure or your manpower and so on. So there's always a trade-off in terms of this. In the perspective of all this, what has evolved, particularly very significantly in this millennium, is a bunch of techniques called agile techniques. Agile, you understand, agile is very responsive to change request. Which says this person is very agile, jumps up, does something, always is ready to react to the situation and so on. So agile again is a is something which is iterative, incremental, but it adapts to the customer satisfaction through delivery of software, actual delivery of software. It's not just prototypes. Internally, within every agile cycle, it might do RAD, it might do waterfall, it might do, again, within that, another refinement. But what it does, as you can see, that it is doing these iterations in cycles, and typically they are in the span of 2 to 3 months. And this is where the software is actually delivered. So, in agile development is very good in terms of long-term ongoing projects, and there are a variety of ways that you do agile, and some of them known as extreme programming. I'll talk about it a little later, or Scrum. You must have heard about these terms from your seniors who are already working. So this agile approach to the whole thing. So what you're changing is not only the whole idea is to reduce the risk of quality and productivity. So the core idea is for going for iterative, incremental. But what Agile brings in very strongly, and we will see that it brings it in at a very granular level, that there are checks and balances at every point. Some of the checks and balances are after one cycle, which is with the customer. Some are discussions with the customer. So you have a 2 to 3 month cycle to deliver, some of the functionalities. So when you do that, the customer certainly is far more engaged. But within this 2 to 3 months, maybe every week, you may have a discussion meetings with the customer, just sharing the progress, discussing about where you are and so on and so forth. Then but the main approach of agile is to remain agile. So even if you have a meeting, it is not like brainstorming meeting going on for 2 hours and so on. Those are not. Agile meetings typically has a fixed time, maybe 15 minutes, maybe half an hour at the maximum. Then you have a kind of maybe on a regular basis, you'll have a team meeting. Typically happens at a daily basis. You have a team meeting. But the agile team meetings are characterized by the fact that it's not like a meeting as we perceive, that you book a meeting room, everybody goes there, brings his or her cup of coffee or tea and sits down, makes a presentation. The agile team meetings are typically mandated that you do not have chairs. Everybody is standing. Why everybody should stand? Is because if you stand, then you will not relax and want to waste time. You know, nobody prefers standing for a long time. And typically, every developer in the team presents one slide saying what that person has achieved in the previous day. And if there are any bottlenecks, but typically these kind of team meetings last for 10 minutes. That's it. So you do not have long meetings, you cut down and all that. But it really helps the entire team within the cycle to remain in the full knowledge of what is going on, who is doing what are the problems. If somebody had need to make a change in the interface because some interface is becoming difficult to implement, then the person who is working with that interface, using that interface, immediately gets to know the sort out things. So it's not long mail exchanges and I have to look into it kind of attitude. No. This is the agile. Even there are people at the desk kind of things where your project lead or senior who just come and stand at your desk and for 2 minutes just get to know what's going on. Right. So agile is an approach. Agile is a culture. Besides being inherently an iterative incremental model where in every agile cycle you have deep customer engagement, and you can within the cycle you can have again several other SDLC models that you make use of. So it is very easy, relatively a lot easier to accommodate changing requirements, regular communication, as I talked of, between customer and developers. Functionalities can be developed quickly and demonstrated to the customer. But the weaknesses are since you are agile, you are always running, and you are doing things incrementally, which means the incremental unit is from month to week to day to hour. So you're kind of trying to achieve certain targets at a very small span of time. So if there are complex dependencies in the project, then it's not a good method, because those dependencies do need long brainstorms, long workouts, and that is not what agile really caters for. And also, to be agile, the team has to have that kind of experience to adhere to this method. So a completely new set of people, new team, cannot usually do an agile. So it has to be a mix of experienced people and few new members who are getting introduced in that whole process. Because you have in this whole thing, since you are agile all the time, you have very little time to learn. You have to learn as you are doing. Right? So that experience gathering is a big challenge. But that's the need of the hour. I mean, as you go to the industry, many of you will be working with this agile model of software development. In fact, now it's spreading over in some of the other development processes also, which are not so soft, like chip design. That chip design is also involving a lot of agile model for their activities. So customer is in the loop. It improves quality, reduces low rework, but certainly it may slow down development if you are not able to plan and break down the requirements properly. Agile approach has a fail early life cycle. So earlier we saw waterfall, the potential risk was going up and up. In agile, it is high at the beginning because you have not understood everything, you have not analyzed everything, you are still trying to do something. So the risks are higher in terms of time. But as the time goes on, you are doing regular 2 to 3 months delivery of the software with well-defined, all well-defined quality and requirements, complete specification, all that. So it kind of requirements stabilize and your quality of development stabilizes. So the potential risk keeps on coming down. And it is preferred by the customer, preferred by the software development companies because of, I mean, this is one of the early fail early life cycle is one of the very positive characteristics of agile for which people love it. And then there are business consequences, of course. Fail early, your cost is less. If you are doing quick agile cycles, it is much easier to invoice the customer. It's much easier to keep the customer engaged and so on and so forth. There are different variants of agile. I'll just mention this. One is, you know, for purpose of creating fun, it's named as chaos. Chaos is a comprehensive. Chaos stands for Comprehensive Human Appraisal for Originating Software. Right. So there's a Standish group which annually publishes a chaos report. For decades. So what they do is they basically analyze various projects that are going on in the world and analyze them based on 10 success factors. So these are the 10 success factors. And this is the kind of weightage that the Standish group particularly recommend, that user involvement is 20 points, total of 100 points, of course, over the 10 factors, but not equally. User involvement is very high, 20 points. Executive management support. Does the management of the company supporting the project, supporting the development. Clear business objectives, 15. Experienced project manager, 15. Small milestones, 5. And you can see that, then don't get shocked. Competent stuff is only 5. So what it says is the success of a project is not, it's dependent, but it's not only significantly dependent on your technical skills. You may be very well skilled, you may be very competent, but if these higher order factors are missing, the project will not succeed. So obviously no project requires all these 10 factors to be successful. Something here, something there puts it off or fails it. But more factors being satisfied, you certainly have a higher confidence. So based on that, several companies appraise their agile executed projects in terms of the chaos 10. This is called chaos 10 because of the 10 parameter chaos 10 factors, and learn from their improvement areas through that and improve their overall software development process. So this was about a whole lot of SDLC models, starting from waterfall. So you can see if you just want to have a quick take back. Waterfall was defining the overall development process and iterative refinement, whether it is RAD, whether it is spiral, or whether it is broken down in terms of agile, is the basic approach, and you have to choose your appropriate way of doing that. So these two basically define all these variants. What I'm going to discuss next is known as TDD, which is known as test-driven development. Right? Very completely very interesting thought. So this is what is being called the old school, where you design, then you code, then you test. Right? Then you come back and design again. That is what we have been discussing. TDD turns the table around. It says design, test, and code. No, just swapping this. So you'll say, how do I test when I do not have a code? So the idea is that in the old school, You design, and based on the design, you code. And then you basically test what you have coded. In the new school, in the TDD school, you design, and based on your design, you design the tests. And then you code to satisfy the tests. You don't code to satisfy the design. You code to satisfy the test. If the test satisfied, then your coding is done. So the advantage here is that your coding and testing gets far better coupled. When you're done with your coding, your testing is done, at least to a good extent. TDD primarily applies to unit testing, which is the big part of testing. It's a group headed by Kent, who has worked on this for a long time, and there are very many proponents of that. So TDD is a technique for building software that guides software development by writing tests. So you first write the tests, and then you write the coding. And TDD is not about testing or development. Rather, it is about design, right? Because the design evolves through refactoring. You have done something, you are modifying it. Run something, modifying it. Developer writes unit test, and mind this word, developers, not testers. It's not like the classical concept that developers do something and then there's a separate group of people who test. No. Developers are the best testers. So developers write the tests, unit tests, and then they code to satisfy the unit test. So unit tests are written in a project. TDD may not be followed. The test could be written after writing the code. That is what we do. And that is called pouting, plain old unit testing. But in TDD, we'll write the test first before writing the code. Now, obviously, there are several disadvantages as well. The testing does not give direct feedback to design and programming, whereas in TDD, the feedback is directly fed into improving the design and program. So that's the disadvantage of the old school, which you try to mitigate. Writing tests for after developing code often results in happy path. What is the happy path? Happy path is what you expect to execute. But there are a lot more unhappy paths in a code, which you don't expect, but they happen. Right? So that's where this inversion in TDD really makes a good difference. So this is what is called the TDD mantra, that you are in 3 states. One is in red, where your tests have failed. One is in green, then you have passed the test, and then you go back and refactor. Refactor means you eliminate duplicates, something which is not properly done, you change that, make it a better design, and then you go back. As you do that, your tests again fail. So then you go and fix them. So you get to green, test pass, you keep on doing this. So that basically getting green is the best practice in TDD. So TDD's philosophy primarily says you may not write production code unless you have written a failing unit test. Test first. You may not write more of a unit test than it is sufficient to fail. Just don't write a whole lot of tests. Just write as much test as is required for the failure. You may not write more production code than is sufficient to make the failing unit test. You are optimized mode. It is found several times in a project that a lot of code have been written which actually never execute, because those situations do not actually exist. So you cannot even test for them. So neither you write superfluous tests nor you write superfluous code. That's the basic laws of TDD. So this was what I have been saying in a meta diagram. This is code-driven testing, and this is the new school of refactoring and doing the tests. So there are several benefits. It gives a better design, safer refactoring, better code coverage. Code coverage basically means that given a code, given a software, and a set of tests that you have, if you run the tests, run the software on the tests, what are the source lines that get executed at least once? So if you have 100 lines and you have 10 tests, so you run this 100-line program on the 10 tests. And if out of the 100 lines, 35 lines get executed, 65 lines do not get executed, you have a 35% coverage. It is impossible to get 100% code coverage in any reasonable project, right? But getting better code coverage is certainly gives you better confidence. TDD is good for fast debugging. It is self-documenting test because you are always doing this. Now, naturally, the flip side of this is it is good to say that I will write the test first, but how? If you write the test in plain natural language, as is done in the test plans, then it will be very difficult to make it sure that your unit test is actually executed and it's satisfied and so on. So what it does is, and it's that move started with Java, they created something called a JUnit. This JUnit is a test class which is attached to the design class, so that whenever you instantiate an object of the design class, it automatically executes the test class or the test functionality. So that's the basic idea. So you have JUnit originally, then C++ produced a CPP unit. Python has that. .NET has that. Unit test framework is there. Now, given this, there has been a novel thought process that why not? Why? So a JUnit or a CPP unit is something kind of a library which is external to your language, because you never consider test to be a part of your development process. So DLang, as it is called, the language D, which is primarily inspired by C++, includes the test as a part of the language. So you can see here you have a class sum which adds two integers, and then you can directly write a unit test. So this says new sum, and you have written, these are the tests written here. You are saying it's a new sum object, and you do sum.add 3, 4 equal to 7, and you assert on that. So if 3 and 4 does not add to 7, then you'll have an assertion here. The program will get terminated. Now, this is naturally very rudimentary example, but the idea is to show that also, but primarily asserts are used, are the process that where every such assert is actually a unit test case. So you define what are the different kinds of tests that you need to do, and for each you write a unit test case. You can try out this philosophy at least in your fraction, int, or poly design. Right? And there is a major reason to use assert, because assert is something which exists in the debug build of the compilation. In the release build, you can just have a switch and put off all the asserts, so that the release build, when you are actually using the software or delivering the software, does not have this overhead of unit testing happening on the time. So this is one way. Then we have my function, which takes an array of type T, and you have the length is greater than 2, then data.length is greater than 2 to data 0 is data 1. So these are all constructs in DLang. So safe, at safe, no throw. That is, this unit test will by itself not throw. You have an array, you pass that array to this and assert. So what will happen if I pass 1, 2, 3 to this function? D0 will get D1, right? So 2 will be copied to the place of 1. Right? That is the functionality. So what do you expect after this? That the array will be 2, 2, 3. So you assert array 2, 2, 2, 3. Looks like C++. Again, looks, not all syntax of this will work in C++. But DLang is a derivative done from C++, which has, which does not try to retain the backward compatibility. It's a new language, but derivative from C++. For example, there's no pointer in steps of that. But DLang's major philosophical contribution is in terms of integration of the unit test in the languages. It's a guy called Alexander Andreescu, who is the primary developer for this, and its compilers are now available publicly. So this was about the TDD. Finally, a little bit more word on Agile. One of the main ways of doing Agile is known as extreme programming. Right? So there are typically 4 factors in the project. One is the scope of what you want, how much you want. One is the quality. How good are you to your commitment? And certainly, what is the cost? What is the time? If you think about waterfall, then this is the primary triangle. The waterfall controls has a fixed scope, has a targeted cost, and a targeted time. So this is the triangle. So if any end of the triangle is not being met, what is your free parameter? Your free parameter is quality. So you vary the quality. You do some little less number of tests. You do not write some of the exception cases, so on and so forth. So the quality gets compromised. That's how you manage. If you have to keep that is, if you have to keep the project with all functionality within the cost, within time, often you would compromise on the quality. In the Agile, the philosophy is different. Again, out of the 4 factors, you put quality as a corner point. You have to meet the quality. No compromise. To be on time, to be within cost. So what can you vary? You can vary scope. That is, do less than what you had thought of. Now you will think, why will customer agree? Yes, customer would not love to agree, but you can see that the Agile is going in incremental cycles where everywhere the customer is there. So the customer would be very aware of, the progress, the compliance to quality, cost and time, and would understand that why you want to change scope at certain points. It becomes much easier. And so whatever you deliver will be perfectly on the quality within the cost and time, but may have a lesser scope. So that is how the planning becomes different. That in waterfall, the constraint is a requirement, and you have cost and schedule estimate. Schedule is time. So this is driven by the plan. Whereas in Agile, the constraints are cost and schedule, and the driver is value or vision for the features. Features is scope, right? So that's the basic difference. So there are several Agile methods, of which some extreme programming is very popular. Scrum is really popular these days. Extreme programming again came from Kent, the proponent of TDD, as I said. So this is just a different view of the agile, like we talked about, there's a release plan, the iteration in weeks, acceptance tests, a stand-up meeting, as I was saying. Then extreme programming has a nice idea. It's called pair programming, pair negotiation. That is, uh, you program, you develop as a couple. Two developers work together, and while working, both of them are not working. One will work, and the other will actually observe, give feedback, give suggestions. But one is primary, and that role keeps on switching between this pair from time to time. It could be every day. It could be, based on a week or so on. So the way it helps is when one person is working, that person has a bias to make errors. The other person who is observing does not have that bias. So while it feels that, two people doing the same work is going to increase cost, but a lot of extreme programming driven projects have shown that actually it does not. Actually, it helps to get the right quality and usually within the given cost. So pair negotiation and pair programming. Pair negotiation is where you discuss and agree who will do what and how it should be done and so on. So that's done on an hourly basis. You have unit tests happening in minutes because we are doing the test driven, and then actually at levels of seconds we are doing pair programming. So I think it's time. Yes. So there are little things left which I'll take up in the next class. If there are any quick questions, I can take that. Otherwise, we'll close. Any questions? I think there will be many questions. The best would be that you write those questions to me so that I can address in the next class, or keep them noted at your end so that you can ask in the next class. Tomorrow is Holi, so happy Holi, and therefore we have a holiday. So we'll not meet tomorrow. We'll meet in the next week. Thank you very much. Have a nice day.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.